Hello, good morning. Welcome. After a long time, I am going to upload a video for class 9 of chapter periodic table or classification of an element. I have uploaded already 4 or 5 videos of this chapter, and the last topic of this chapter I'm going to upload. That topic is electronegativity. So you try to understand what is electronegativity and what is the factors on which electronegativity depends, as well as we will see what is the periodic trends for electronegativity. The topic is electronegativity. In short, it is denoted by capital E and a small a n. Don't write symbol in a small letter, else you will not get mark in board exam. What is electronegativity? You know that you have studied somehow in class 8 electrovalent bond, covalent bond, and very soon I'm going to provide video of that topic also. But just there is some use of that bond, so I'll explain here a little bit. You know that covalent bond is formed by the mutual sharing of pair of electrons between two combining atoms in a molecule. It means in a bond there are two electrons which is shared by two atoms. Okay, suppose an element A and B is in a compound and both are share one electrons each. Means atom A is sharing one electron of B and B is sharing one electron of A. So these electrons are called shared pair of electrons. What they are called? Shared pair of electrons. Electronegativity said that, or it means the tendency of an atom in a molecule to attract the shared pair of electron towards itself. It means there are two electrons which are shared by both the atoms. If the tendency of B to attract the electron is more, it means we can say if its electronegativity is more. It has tendency to attract the shared pair electron towards itself. The B has the tendency to attract the shared pair of electron towards itself. That property is called electronegativity. It means B is attracting, or we can say accepting the paired electron towards itself. Okay, this is called electronegativity. So in short, we can say that the tendency of an atom in a molecule to attract the shared pair of electron towards itself is known as its electronegativity. Electronegativity is a dimensionless property, means it has no units. It only indicates the tendency of an atom in a molecule to attract the electron pair or bond pair. It is also called bond pair. Share pair is also called bond pair towards itself. The electronegativity was measured by that value of different atoms or elements. The electronegativity values was measured by different scientists on different scales. But at the last, The wisely used scale of electronegativity was given by Pauling, that is called Linus Pauling. And he found that in whole periodic table, the highest value of electronegativity is fluorine. That is 4.0. And the lowest value of electronegativity in the whole periodic table is CS, cesium, or you can say calcium, or generally we say cesium. So question can come, which element possesses highest value of electronegativity? So answer will be fluorine. And which is possessing least value of electronegativity? So answer will be CS, symbol is CS. In book, the value of electronegativity is given, but it is not compulsory to learn till your level. You only remember the whose element possessing maximum or highest value and which is possessing least. But we should know that in period or in group, the value of electronegativity increased or decreased. That I'm going to explain just after 2-3 minutes. Before that, I'm going to explain on what factors electronegativity depends. So I hope I'm clear with this topic, electronegativity. If electron pair or bond pair is shared by an atom towards itself, that property is called its electronegativity. It depends upon two factors that already we have studied in the whole chapter, that IP, electron affinity, atomic radii. There are so many topics we have studied, and on what factors they depends. So the factors on which depends this electronegativity, first is atomic size, and second point is nuclear charge. As I have already discussed in the previous topic or previous video, I have given to you that atomic size decreases when we go across a period. At the same time, nuclear charge increases. Means in nuclear atomic size decreases, it means nuclear charge increases. I have discussed on this topic already. And also we have studied that when we go down a group in a periodic table, atomic size increases. Yes? So what is the conclusion? If you will take example, suppose if you are taking example H and F, there is a bond that is called single covalent bond. You know that hydrogen valence electron is 1 and fluorine valence electron is 7. And fluorine wants to achieve octet structure, and hydrogen wants to achieve duplet structure. So both will share a pair of electron, and that case a bond will form between H and F, and that bond is called single covalent bond because they are sharing one pair of electrons. So they will share a pair of electrons, and because of that a bond is formed that is called single covalent bond. As you know, when we go across a period, size decreases. If its size decreases, it means it is smaller in size as compared to hydrogen. If its size increases, if you make a orbital structure of fluorine, you can see that you will find that because of the smaller in size or smaller in atomic radii or radius, the force of attraction between the outermost electrons and nucleus, where the positive part or proton is present, will be more. It means it has power to attract the shared pair of electrons towards itself more. It means this fluorine will attract the electrons which is shared by both the atoms towards itself. So as the conclusion, we can say that As we move across a period, atomic size decreases, nuclear charge increases, therefore electronegativity increases. As size decreases, the attraction will be more. The force of attraction will be more, means the tendency to attract the electrons will be more. So what is the conclusion? Conclusion is atomic size increases, nuclear atomic size decreases as we go across a period, nuclear charge increases, the force of attraction or tendency to attract the electrons increases. It means electronegativity increases as we go across a period. Across a period, radius, atomic radius decreases, electronegativity increases. Okay, now we'll talk about group. When we go in group, down, top to bottom, when we go top to bottom, as we know, radius, atomic radius increases. If atomic radius increases, size will be bigger, then the attraction between the nucleus to the outermost electron will be less. Means the tendency to attract the electron towards itself will decrease. If that tendency decreasing, means electronegativity property decreases. So conclusion is, as we go down a group, atomic radius increases, nuclear charge decreases, and electronegativity also decreases. So we can say that electronegativity is reciprocal of radius. It is reciprocal of radius. If radius increases, means electronegativity decreases. If radius decreases, means electronegativity increases. So this is also called the periodic table. So question can come, what is the periodic trend? So you can write in short also. This is just giving the small key to understand where it is increases or where it is decreases. So as we go across, radius decreases and electronegativity increases. As we go top to bottom in a group in periodic table, radius increases, electronegativity decreases. So this is the periodic trends. So question can come. How question will come? Will come arrange the following elements in increasing or decreasing order of electronegativity. Question is like that. NFO, arrange in increasing order of the property electronegativity. Okay, it may come in decreasing, it may come in increasing, and whatever direction is given that you have to follow. Increasing means smaller to bigger. You have to write the first lowest value of Vn, then you have to go as electronegativity increases. That is called increasing order. If question will come decreasing order, decreasing means first you write the element which possesses maximum or highest electronegativity, then you go on as electronegativity decreases. This is called decreasing order. But here what direction is given? Increasing order of En. So how will you arrange? First you should know that is these all elements are of the same period or same group. So how would you know these elements of the same period or same group? So for that you have to write atomic number and their electronic configuration. Nitrogen, as you know, is electronic configuration is 2 and 5 because atomic number is 7, and fluorine atomic number is 9, its electronic configuration is 2 7, and oxygen atomic number is 8, its configuration is 2 and 6. One more concept is if atoms possess the same number of cells are same, means they are belong to same period. See, you can see that all the atoms have two cells, K cell, KL, 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 all have two cells, means they are present in second period. This is the you can say key. You can get that of which period by looking the number of cells. So all have the same cells. Now we have to find out if that which element present in which group. Accordingly, we will arrange. You can see the last number of electron. What is the number here? 5. Means it is in the group of 15. It is in the group of 15 nitrogen. Then 6. This is the 6. Means here will be 16 oxygen. And then is 7. Means it is in which group? 17 group. Halogen group. So we will write 17. Here will be fluorine. This is arranged in periodic table. No, this is not the answer. This is only I have arranged in periodic table, where it is present in periodic table. It is arranged like that in the periodic table. Now we'll go to the trains of electronegativity. As we know, these are of the same period elements. So we will look what is the periodic trend of electronegativity in periods. As we saw that as we go across a period, electronegativity increases. Yes, it means this is the period element. Yeah, same period elements. It means as we move from nitrogen to fluorine, electronegativity increases. Yes, then whose element possesses the least electronegativity? Which is left hand side, and which is possessing maximum? Which is at right hand side, because this is arranged according to periodic table. So we can say that the correct answer of that question is increasing order will be nitrogen, oxygen and fluorine. This is the answer. So this type of questions is possible and will come in exam. So you keep practicing. It is given in the exercise questions. You can do from the other book also, but you try to follow the Selena publisher book that is I think given by the ICSE, and that is useful. Direct question comes from this book. So I hope I am clear with this topic, electronegativity. One more topic I am going to explain here, that is you are very familiar with that topic. You have studied from class 7, 8, 9 and again I am going to give in class 9. Atomic number and atomic mass. You know that it is atomic number and atomic mass, but again I am going to give very short. Suppose X is an element, any element. Here is Z and here is A. Here Z stands for atomic number. Okay, and A stands for atomic mass. Okay, this X is an element. It may any element. So what is atomic number? Question can come. What is atomic number? What is atomic mass? So let's understand. Z is equal to total number of protons, or is equal to total number of electrons. So what will be the answer? Definition of atomic number. Atomic number is defined as the total number of protons present in center of an atom, that is nucleus. The total number of protons present in center of an atom, that is in nucleus. That is called atomic number. An atomic number, you can write in short, it is equal to P plus proton plus, and which is also equal to E minus means electron. Second question, what is atomic mass? So atomic mass is the sum of total number of protons plus total number of neutrons present in the nucleus of an atom. Once again, atomic mass is the sum of total number of protons and total number of neutrons present in the nucleus of an atom. Here 0 means it has no charge, plus means it has positive charge. Okay, you can also write the same N neutron is equal to A, and as we know P plus is equal to Z, so you can write A minus J. So from here you can calculate neutron, here you can calculate atomic mass, and this is atomic number. One question I am going to solve here, just to see. Sodium 1123. See, follow the algorithm in the same way. So what is the Z here? 11. Z here 11. Next is what? Protons. How Z is equal to proton? So you can say proton is equal to 11, and electron is equal to proton. So you can say electron is equal to 11. Okay. Now come to A. A is equal to, you know that, proton. How much proton? A is already given 23, so no need to calculate. So we have to find neutron. So neutron is equal to A minus Z. What is A? A is here 23 minus what is Z? Z is 11. So we write 11. So neutron is equal to 12. So this way you can find electron, proton, and neutrons. If you remember this small thing, you can write the definition of atomic number as well as atomic mass. So most of the topic I try to clear, I try to make you understand of this chapter, and all the topics whatever is given in the book that I have discussed, I have given to you through YouTube video. So you must go through my channel, watch my video. If any doubt, you can ask, you can contact on me on Instagram or on WhatsApp, so I can reach you and I can make you understand. You must like and subscribe my channel so you can get more updates, and very soon I'm going to provide you video of the second chapter of your book, that is chemical bonding. So enjoy your day and have a nice day. Thank you.